Okay, welcome back. We've talked about voltage, current, and resistance, and we've talked about how to measure them using your multimeter. In this video, I want to look a little deeper at how those three things are related, and it's a thing called Ohm's law here in lesson 2. We're also going to look at how does this work with a series circuit and with a parallel circuit, and then we're going to see how might we use this information to design a simple circuit. So this relationship was kind of figured out by George Ohm in 1827, but it actually wasn't really accepted for about another 6 years. So you'd think it's obvious, but it wasn't. So the basic formula is volts equals current times resistance. Now, why do they use V? We know what that is. R, we know what that is. Why do they use I for current? Well, fact is this stuff wasn't invented in the English language. It was either German or French, and they had the word. It had more to do with the word they used was the intensity of current. So they used the I for intensité or wherever that was in French or German. So get over the fact that English isn't the language that's primarily used for everything in science. So there's three ways to state this. A simple way that people often use is they draw this triangle with volts, current, and resistance. And how this works is whichever one you want to calculate, which one you want to know, put your finger on that one, and then it gives you the formula. So the formula for volts is current times resistance. Or if you want to know resistance, put your finger on R, and R equals volts divided by current. Or if you want to know I, put your finger on the I, and the formula is volts divided by resistance. You'll see this in several different websites on the internet. It seems like a handy little way to kind of remember it if you don't know the algebra to switch the equations around. But if you remember volts equals current times resistance, that's the basic form of it. So if you know any two things, you can calculate the other one, the third one. So let's check this in Tinkercad. So for example, here is a resistor in a circuit. Now I can start simulating, but it doesn't show me anything because I can't see the electrons flowing around the circuit. But I know the resistance. So I know that's a 9-volt battery, and I know that's I've created it as a 900 ohm resistor just to kind of make the math come out convenient. So let's connect up. This voltmeter is set to its volt scale, and I'll hook that up here. I hook a black wire to this side, and that's going to show me the volts. Now, notice a couple things. It's negative because I've got it hooked up with my plus going to the negative of the battery terminal. That doesn't bother me. Notice it's a little less than 9 volts. Just because the current going through here kind of drags the battery down a little bit. Okay, let's stop this and let's hook up this one. I want to measure the current. So remember what I've got to do. I have to break the circuit open, and I have to insert this into the circuit. So let's take our red lead and hook it here, say, and then let's take our black lead and hook it the other way. And notice also that one's backwards, so they're both reading negative numbers. It's not a big deal. So let's get out a calculator. So I've got basically 9 volts, 8.99 volts, and I've got about 10 milliamps, or 0.00998. So let's get a calculator and let's calculate what the resistance is. So if I look at my formula here, I put my finger on R, and so my calculation for R would be volts divided by current. So my volts here is 8.99 divided by the current. Let's see, I guess I put my calculator here where you can see it. Now I forgot where I was. Let me start over. So I'm going to say 8.99 divided by 0.00998. Is that right? Okay, and notice what I got here. I got 900.8. So that was the value of my resistor. I know it was 900. So you can see how this relationship works. So when there's current flowing through something, you can calculate any one of the three that you don't know. All right, so let's see how this looks with some different circuits. Let's bring out this circuit I was looking at before, for example. So basically in a series circuit, the same current flows through everything, but they share the voltage, or what's called the voltage drop. So the voltage from in this case, this is showing me what I had last time, showing me the voltage across there, across the resistor, is about 3 volts. The resistance total across both of them is my 5 volts. And the resistance, I'm sorry, the voltage across the LED, or the voltage drop in the LED, in this case is about 2 volts. So notice that the overall voltage was 5, but the voltage drop here was 2 and in here was 3, so the 2 plus 3 add up to 5. So the voltages throughout the series circuit add up to the total. And notice I'm measuring the current. Now the current is the same in both because it's what it is. I can put this in different places in the circuit, but that same current is flowing through here, and back to the Arduino. So that's just the way a series circuit works. It has the same current, but they share the voltage, or they split the voltage drop. So let me bring up another one where I had a parallel circuit. So in this case I have 5 resistors, and notice I have, the plus voltage goes to the same to one end of them, it's the same, and the negative, the ground voltage is they share that. So if I start this simulation, they all have 5 volts. So every one of them has 5 volt drop from one end to the other. But if I was to measure the current in any one, it would be less than it was before, because the current is split between all of them. I mean, actually, I can compute the current now, right? Because with Ohm's law, I know there's my resistance, there's my voltage, so I could compute the current, and any one of them is the volts divided by resistance. So I'll just show you another one. I created this very similar circuit as a series circuit. So here's the same circuit with the 5 resistors in a line. And if I simulate this, okay, there's 5 volts from here to here. But if I for example pick any one resistor, which one do you want? Okay, I hear somebody say the third one. Let's take the third one here. This is the third, from here to here. So that's 1 volt drop across that one. Now if I measure every one of these as 1 volt each, and so it's 1 plus 1 plus 1 plus 1 plus 1 equals 5. Now if the current, I can do this if you want. I can stop this and say let's hook up the current this way. Just quickly put that back to ground. And this current, this 5 milliamps, is what's flowing through every one of them because they share that. So notice what's different between parallel and series. In parallel, they all had the same voltage drop, but they split the current. In series, they all have the same current, but they split the voltage drop. It's just a little different. Let's not make it more complicated than what it is. But how do we use this information? Let's say, for example, that I want to design the circuit. Like, for example, this little circuit we've been using. I'll pick this one here. How did I know what value of resistance to use so that I wouldn't either blow out my LED or have it be too dim? If I use a resistance that's too high a resistance, not enough current flows, and the thing doesn't turn on. If I have way too low a resistance, I get too much current and I'll damage it. It'll either wear out quickly or it might blow out instantaneously. How did I design that? Well, let me draw a what I call a schematic for the circuit. So they use little symbols. So let's say I have a battery I draw like this, and let's say it's a 5-volt battery. It's really Arduino, and then it goes around here, and then it goes through a diode shows like this. The triangle kind of shows that the voltage, let me blow this up, the voltage only goes in one direction. And to show that it's a light emitting diode, they put some little arrows here to show the light coming out. And then we go down to a resistor. They often show these as a little squiggly line like that. And then it comes back around to the battery. Well, what I know about the LED is basically I look on the internet and find what it's supposed to be, or I go to the manufacturer and they tell me that it should use about 2 volts, and they want it to be no more than 20 milliamps, or let's say 0.02 amps. And just to make it last longer, let's use a value more like 0.014 is what they've been using in some of these circuits. So I want that to be my current. Now let's see what do I know about a series circuit. Because they're in series, they kind of split the voltage. So if I have 2 volts here, I'm going to have 3 volts here. And the current, if I want to have this current flowing through the whole circuit, this is going to also be 0.014 amps. All right. So what I want to calculate is what is the value of R. Well, I can calculate the value of R with this formula. I'll put my finger on the R, and I'll take the volts divided by the current. So R equals the volts, which is going to be 3, divided by 0.014 amps. And let's go bring up our calculator again. So if I have 3 volts divided by 0.014 amps, it says, okay, how about a 214 ohm resistor? Well, I have some that are 220 in my kit, so why don't I use those? So that'll be approximately 200, actually, 220 ohms. So that's how I can use this Ohm's law to kind of design, knowing what a series circuit does, how it shares the current. I know it shares the voltage drop, or splits the voltage drop, and it shares the current. It's the same current. I know, with what I know, I can then calculate the resistance in this thing, because I know the voltage and I know the current. I can calculate the resistance. So that's how you can use this information to kind of like design a circuit. Let me just show you something else I haven't shown you yet. Notice what I drew here. I called it a schematic, or I drew with a little symbol. In Tinkercad, if I click on this little button here, it says Schematic View. So Tinkercad has the ability to show the circuit as a schematic, like I like to draw on paper. Now it doesn't use exactly the same symbols, but notice for the diode, it's got the diode symbol with the light coming off it. For the resistor, they just show it as a rectangle. A lot of times people will draw that little zigzag line. In this case, I've got an Arduino here. Let's go back and show you another one. So what's the use of a schematic? Here's a circuit where I've kind of drawn it all goofy. So that's hard to see, right? But in the schematic, if I ask for the schematic, it puts it in a nice, neat. It doesn't care what it looks like in the real world. It looks like this is what the electrons see. They go from the battery to the resistor to the diode. Now, Tinkercad does this funny little thing. It shows you the low voltage of the battery and the high voltage of the battery. So you have a test point of your circuit. But basically there's these three things in the circuit in series. So you can clearly see it's in series, and you can see the little symbol. So that's kind of the use of a schematic. It shows it in a different way that's very logical. In your Student Kit website for Lesson 2, there are 3 activities for you to work on. The first one is called this external LED activity. And here's what the schematic looks like. We've actually talked about this circuit a lot. So you might want to try building it yourself. Very simple circuit to see if you can do that. Down at the end, there's 2 more activities. A series circuit activity. Again, here's what the schematic looks like for that. And then a parallel circuit activity. Show you you can see how it looks different because they're in parallel. So those are those 3 activities for you to do on the student website. So in the next video, we'll see you when we'll start out maybe talking about getting into the coding of the Arduino. What are variables, and just basic coding of how do we set it up. Okay, I'm looking forward to seeing you next time.